In this video, I am going to demonstrate how to use uniTank to register a small tank internally when there is little internal structure, such as column and gauge poles, to register the vertical rotation. So first off, I'm going to estimate the radius of the tank. So I'm going to find an elevation where I know I have shell data. I'm going to use the circle tool to draw a circle. Then I'm going to fit that circle to the data, and I'm going to fit it to the first layer. I do not have the all layers and definitions checked off because I want to fit it only to the first layer. So the circle now is fit, and now I have an estimate of the radius, which is 23 and 5 inches. So I'm going to put that up here. It just has to be approximate. So we're going to run the course auto register on all the layers. As you can see, the auto register has positioned the layers correctly, but it has failed to rotate the layers properly. And this is because when we do the auto register, we expect a certain level of asymmetry between 3 and 5 feet. This is typically where we have manways and nozzles and columns. But for this tank, where we have little feature, internally, there is not much that we can lock onto to control that rotation. So that's fine. All we have to do is just run the rotation separately, like we do in the external registration case. So what I'm going to do is I'm going to try to find a cross-section with asymmetry in the tank. So between 1 and 2, we have these nozzles in here which are going to give us the ability to rotate the tank correctly. So I'm going to do the course rotate. I'm going to do it to all layers, and I'm going to use the first layer as the reference layer. And we're going to run it between 1 and 2 feet. There. So now it has registered the rotation properly. What we're going to do is we're going to just ensure that the elevation is correct as well, because we have done a rotation. We want to re-elevate the layers. What this function does is it matches all the elevations in the tank on the floor. So now we've completed the course registration. We're going to go right to the fine registration. So what we're going to do is we're going to define our fiducials like we do in the regular internal registration case. Now what you'll see is that we have fiducials on the floor, we have fiducials on the shell, and these will help us with our X, Y, and Z translation. What we don't have right now is any fiducials that will help us with our rotation. So what we need to do is we need to find a couple features in here that will help us with that. So we can use nozzles. As long as there's a good overlap, we can use this nozzle. So what I'm going to do is I'm going to find a thin cross section, and I'm going to place a fiducial on both sides of this pipe. So using the point tool and ensuring I'm at the right elevation, I'm going to drop 2 points on either side of this pipe. Again, we want to make sure that the surfaces that we're using has overlap between the scans. So I'm going to define a surface fiducials, 2 surface fiducials that control horizontal translation and rotation, and I'm going to make them quite small. And as you can see, they'll put them as in right there. We can also look at this nozzle. We can kind of do the same thing. We may need to adjust our elevation to find one where we get some good vertical surfaces. So there we go. So just a note on defining fiducials. When we use this define fiducials button, if we select an area using the rectangle, circle, or polygon tool, the tool will automatically find the fiducials. For example, if I come to this manway and I select this area and I say define fiducials, surface fiducials, looking for small fiducials here, it will search for flat surfaces in this area. And that surface may be a bit small, so I'll demonstrate it on the shell here. So if we select an area, it will automatically create fiducials and find those surfaces for us. If we use the point tool as we did before and just place points, so if I just place a point here, it will create a point fiducial right at that location. So again, we can look at this pipe as well. We can drop a couple of fiducials on this one. We just want to do it on the side that has overlap. The other side right here where we only see the red scan is not going to be useful for us. Now if we had some features which looked like a column, such as the bottom of a nozzle, we could also try using that. These nozzles don't really lend to that, but we can see if there's some other features in this tank. So we got another nozzle up here. So again, we can just keep dropping these if we want, kind of strengthen up the registration process. And when we feel like we've gotten enough enough fiducials, we can run snap fiducials. So I'm just going to add a couple more here. So we can use manway, the lips of the manways. We can use pipes and nozzles as I've shown you here. If you have a column in there, we can manually add column fiducials. So what I'm going to do now is I'm just going to run snap fiducials. And should be able to see these data sets come together really quickly. So we have, after 33 iterations, it shows down here how many iterations it took for the snap. We achieved our optimal solution. So we can run it again just to see if everything converges, and as you can see, this number of iterations decreases. It'll never go to 0 because there's always a little bit of movement in the system, just because there's noise and things like that, but it should get pretty close to 0. So if we run it for a third time, there we go, we got two iterations. So we can inspect the model and just see that everything is in line correct. Now just another note, because this tank is so small, we only have 2 floor fiducials. What we can do is we can again manually add more fiducials. So if I just select an area, I can define fiducials, and if I select an area, it will look for fiducials in that area. So if I look for vertical fiducials, and we can decrease our spacing here to 3 feet, it will go in there and it will look and add more fiducials for us. Similarly, we can do it on the tank as well, on the tank wall, because I believe this one only put in about 4 fiducials. But what we can do is we can just select the shell. We can do define fiducials, and we can define horizontal fiducials on the shell. And so this way it can populate with many more fiducials. So if I run snap, I don't expect too much movement in the system, but it will give us a new result because we have added that many new fiducials. If you ever want to see what the fiducials, the surfaces that were detected look like, or what were used, you can select these fiducial layers, and what you will see at each fiducial is that you'll see the surface that was fitted to the data. So each one of these fiducials are going to have surfaces inside with colors that correspond to the layer that it was selected from. So we can have a look at the manway. So there it is. The manway is very tight. So it was only able to use the green and the cyan layers here because there's no red data, so that you don't expect a red ticker here. So just a couple more features I wanted to show you on this tank. So we did run the auto rotate here for the course registration last time. Now if that doesn't work for you, there's always manual options. So if we hold down Control and Shift, what we can do is we can move a layer around manually. And I go through this in the external registration videos, so you can look at those for more detail. So if I wanted to rotate the green layer to the red one, we can have a look here. If I hold down Shift and Control and then do right click, it rotates the layer. And so what I can do is I can just go manually shift it into place. Now I can do the same for the blue layer. Now if I do shift click, left click, it moves the layer. But I don't want to do that right now. So I'm just going to undo that. What I want to do is right click and shift control, move the layer. Now what we can do now is we have a couple more additional movement tools. So if I wanted to really refine this registration manually, what I can do is I can look for overlap in the layers. So if I wanted to bring the blue layer to the green layer, what I can do is just draw a line between the separation and do line rotate, and that will bring me there. I can also use these tiny fine-tuning options to move it very small increments. So now we got the green and the blue together. We just need to bring the red one over. So what we want to do is just find a very thin slice of data, like right there, where we can see where the layers are, and what we can do is we can just bring the red one over here and ensure that you have the right layer, you're working on the right layer here. But what you can do is you can do that line rotate, and we can nudge it. Now we don't have to have it too accurate because we're going to do a fine registration on this data set, but I just wanted to show you all the different tools we have in uniTank to be able to manipulate the different layers and come to a course registration quickly.